Today we're going to discuss about a new topic called threads. So, what are threads actually? What is multi-threading? When are they used? How are they helpful? So, all these questions will be answered right now. So, basically, threads are something like this. Let's say you have a CPU. Well, of course, in your laptop you have a CPU, right? So, when you buy a CPU, you just check that is it AMD Ryzen 7, Ryzen 9, 5000, 6000, or it's Intel i9 12900 KS, i7 12650HX, or UE, or whatever. So what are they? So basically what happens is threads are tiny subprocessors. So they are the subprocessors of the code, you could say them. So what happens is thread let us use they use shared memory. So you can run two programs at the same time parallelly. Let me give you a quick example. Previously what used to happen is, let's say before threads, you could just use one app at a time. Let's say if it is Excel or let's say it's Word, then you can use it only once. So when multi-threads came into handy, so then in that situation, what's happening is you can right now we are able to use multi-threading in our system. So that means you're using Spotify and you're listening to some songs, you're opening File Explorer and checking few PDFs or and browsing through internet and writing some assignment in Word and all the stuff. You're doing everything in the same time based on the RAM and the core system and all the stuff. So because of that, because of multi-threading, we are able to do all this stuff. So if you were a gamer or if you use it to play GTA 5 online, so previously what happens is in a thread cycle, one thread used to consume maximum amount. For that reason, one of the modder fixed it. So and that mod was added into original Rockstar and they fixed it and you are able to reduce the lag time in GTA Online. It was 2 years back, but relatively previously before 2 years, the lag time was too high. So that was because of the thread. So he fixed the thread and it's working fine right now. So basically what's happened is the thread cycles are something which were getting wasted. So if you use threads, what happens is you can utilize the maximum amount of your CPU. So that means instead of wasting the threads CPU cycles, you're utilizing with the help of threads and all. So basically, before getting to multi-threading, so let's check few basic commands. So right now, the main method is running, right? So it also have its own thread. So let's check its name: thread dot current thread dot get name. Now this is basically a return value. So obviously, I need a print statement. So let me just write it in a print statement. So I'll be getting main. Now, if I want, I can just simply change it. Let me just write thread dot. We need to write current thread because it's saying that it's something like this because this holds the object of the current class. In the same way, this thread dot current thread holds the thread of the current class. So it's just simple. Set name. Now let's keep the name as threads. So let me add few s's. Now as you can see, it's the same. So basically, thread have a state like new state, active state, waiting state, timed waiting or blocked state, and termination state. So new state means when you create an object of a thread, it's gonna be in the new stage. And when you give a start method or basically to start a thread, there is a method called dot start. So when you give that method, it's gonna be into active stage. Then is waiting state and timed waiting state. So waiting state means it waits until some other thread gives it space or the CPU allocates time for it or the course for it. And next is timed waiting or blocked state. Basically what happens is, let's say one of the thread is in a critical situation and it's saying that it won't leave until the critical situation ends. So in that case, the next thread which is in the line leads to starvation. That means it's not getting a sufficient amount of CPUs or whatever stuff. So in that situation, it leads to starvation. So in that case, it's gonna be temporarily blocked to avoid starvation. It's not permanent, temporary. It's like dot sleep method where you let it sleep for a while. So wait it. So we're gonna get into it dot sleep method. And next termination is when the thread finish its process or some abnormal thing happens, like you wanted it to stop it by itself or something, you messed it or you made it wanted. In that case, termination happens. So these are the current states. Now threads do have a priority. Thread dot current thread dot, you can set the priority. So the thread's priority is kind of natural number and it's up to 10 maximum. So the current thread's priority is basically it's gonna be 5. You check it. So let me just write it in a print statement to avoid confusion. Dot current thread dot get priority. So it's gonna be 5. Now let's say you created some other thread in this class. We'll get into it. Then it's gonna inherit the current thread's priority. So right now the current thread's priority is 5. I can just simply change it in the same way. So thread dot current thread dot set priority. So let me just make it 6 for this moment. And now there's one more thing called daemon thread. You might have seen garbage collection in Java, right? So garbage collection uses daemon thread. So daemon threads are something which have very low priority and they run it in the background. So if you want to check the current thread is daemon thread dot current thread dot is daemon. That's all. And there is also a few methods that, okay, let me just write it in the print statement. It's a boolean value, so you might get true or false. It's not a daemon thread. The main thread is not a daemon thread because it's not working in the background, right? So it's going to be false. So as you can see, now there are two more methods. It's saying if the current thread is active and the active count. So they are also boolean values. One is thread dot current thread dot is alive. So it says whether the thread is in active or whether it got terminated. So it's true because it's running, right? And next thing is thread dot current thread dot active count. So it's going to say how many threads are running basically. So only one thread because only main thread. Now basically there are two ways for creating threads. One is using extending thread class and other is using runnable interface. So they both have the run method but the runnable interface only have run method and the thread class have both run method and start. So let me just create a class name class thread. Let's say thread1 extends thread. Now we'll get into it. What is the difference between extending thread class and using runnable interface? So for the time being, to make our thread run, so we have a method called public void run method. So whatever you want to do within the thread, you can use it here. So let's say I want to print 5 numbers. So let me use for loop. So let me just keep it 5 and it's going to print. So what if I want the thread to sleep? So I use the sleep method. It's going to print the value of 5. And it's milliseconds. So basically 1 second is equal to 1000 milliseconds. So I'm going to give 1000 and we need to keep it in try catch block obviously. So you can just auto fill it. It has an interrupted exception so that if some other interrupts it or some other thread wants to interrupt it, then it's gonna go into this. So now let me just erase this bunch of stuff, and to create an object of this thread we need to just create an object. So thread1 is thread1 t1 is equal to new thread. That's all. So the thread is created. Now to make it run, so you must type t1 dot start. Of course, now you might be wondering, we wrote here run, then why are we using start? So basically what happens is dot start method have a different call stack. For that you need to know memory management. So I'll explain it to you in just a second. So as you all know, Java uses heap and stack memory. So in the memory management, what happens is, let's say this is the call stack, and this is the place where, and it contains main method. And this is the place where we store all the variables and all the stuff. Let's say int x, int y, reference variables and all the stuff will be stored here. And its value, let's say x is equal to 5, and that will be stored here. So basically what happens is, if you use dot run method, then what's going to happen is it's going to run it in the same method. So that means there is no thread is being called. So when you use dot start method, a new separate call stack will be called, and it's going to run it in the background internally. And it's going to say that this is a different thread and this is a different thread, and they're going to share the print method one after the other in the random order or whatever based on the situation, and then they're going to work on it. So in this way, the difference between start and the run method is, if you use start, then a different call stack will be called and it's going to run parallelly. If you call by just saying dot run, then it's gonna do it in the same stack. So this is this method where main method stays, and this is the place where we declare all the variables. So it's gonna run it in the same stack. So that's gonna be a big mess. Then what's the use of threading? So if you use dot start method, you can create a new thread and all stuff. So that's it. Now if you see here, if I run this, it's gonna say 0, 1, 2, 3. For every second, it's printing because I gave your sleep value for 1000 milliseconds. So in this way, we can just create our own thread by using thread class. So now let me just create by extending thread interface, runnable interface. Just write runnable and just make it, and runnable is an interface, so I must write implements. Now, what's happening here is, I cannot simply do this. So for that, what I need to do is, I must create thread one. As I mentioned earlier, the runnable interface only contains dot run method. So I must create an object of this and then use it in the thread class. So it's something like this, and then I need to write thread object of the thread, and in the brackets I must write R1. So because the object name of this is R1. So with this, then I can call it with t1.start. So many people use runnable interface because, first thing, if you use runnable interface, then only shared memory will be used whenever an object is created. But if you extend by using thread class, what happens is, whenever you create a thread, a new object is created. That means memory is getting wasted. So that's an issue. If you don't have an issue, then it's fine. You can use it. But if you are dealing with large data, many people tend to use runnable. And the next thing is, in runnable, it's memory sharing and all, it's fine. But what if you want to extend something else? Let's say you want to extend, then you can obviously extend, right? If you want to extend a class, right now I don't have any class. If I want, I can extend. I can extend any class, or I can implement multiple interfaces. So that's the advantage of interfaces, right? But if I extend a thread class, then I cannot extend some other class. That's an issue. That's one more thing that will be sorted with Runnable. So many developers tend to use Runnable, but it's up to you. So in this way, we can run it. So now let me say to you guys one more method called join method. So let me make two, two, two. So if I run both of them together, it's gonna give you some other. Oh, let me just create an object so that I could say that this belongs to this. Let's say string s thread 1. Now I'll just print out the value, or else let me just print it out here. Now if I just give a gap, then you could just say what it belongs to. Now I need to give something, so let's say it as A, and let's say this one as B, so that you know it's from which thread. Now as you can see, if you have 3 or 4 threads, then the order is going to be really different. So now I want to say you guys a different method called join. So T1 dot join. By using this method, what happens is it's gonna run only when the first method is finished. So let's say when T1 is finished, then only T2 will be started. So previously we got output like this, right? As you can see here. Now let me just do it. So whenever A is finished, then only B will be started. So in this way, we can use dot join method to finish them. So this is one more method so that you could use when one thread finishes, then only you can make it to implement other thread. So in this way, hope you guys threads concept is clear and you are perfect with all the basic syntax and all the stuff.